Ladies and gentlemen, please welcome our next speaker, Boaz Ziniman, presenting the topic, Serverless Systems That Won't Burn a Hole in Your Pocket.
Okay. How are you doing? It's a bit, I can't actually see you, but we'll try to have some interaction later on. So first of all, thank you very much for joining me. I'm really happy to be here. My name is Boaz. I'm leading the developer relation organization of AWS in EMEA. And I was actually born here in Lithuania, in Vilnius. So this is something that makes me really excited to speak in Vilnius and speak about my favorite topic, serverless. And today we're going to talk about serverless from a slightly different perspective. We are going to talk about cost. How can we make our serverless applications or serverless functions to utilize the resources that are given by AWS in the best way possible? And I'm a huge fan of serverless. I've been following this technology since the first day it was announced. I run an AWS account that I'm not paying for because this is part of my job. And I don't have a single server running in this account. I'm very proud about it. And I've been using serverless for everything I can use for that. And I want to share with you a eureka moment I had back in 2014. So back in 2014, I was sitting at the keynote of reInvent, Werner Vogel's keynote. And then Werner came on stage and made this announcement.
Ladies and gentlemen, please welcome Chief Technology Officer of Amazon.com, Werner Vogels.
Good morning, Las Vegas. Today, we are going to add these primitives to AWS with a new compute service. I want to introduce to you something that's very exciting. It is AWS Lambda, which is an event-driven compute service for dynamic applications.
So think about it. An environment with no servers, with no infrastructure, nothing for you to manage, to run the code for you. I was a web developer back then. I used to run several teams that were around web development. And 50 seconds later, I start thinking, how can this change completely the way we work? So it took some time. It took 2 years for Lambda to become GA, and then a lot of other parts of the architecture to evolve. And now we have a lot of components that are working together in this serverless environment. But this is something that really changed the way I think about software, about how we develop. And when we build modern applications, especially those that are based on serverless, there are all kinds of goals and aims for that. We want to create something that can be highly available, manage large amounts of data, scalable, secure, great performance, and many, many other things. And usually cost comes in a much later stage. And there is a very good reason for that, by the way. It's really, really easy to start. And it's very, very cheap. We'll talk about pricing later, but the basic cost of a single Lambda invocation is a fraction of a fraction of a fraction of a cent. So usually you don't think about cost from the beginning. And then you meet the real world. You meet real customers, sometimes millions of customers. You meet data, piles of data. And you meet your CFO that suddenly becomes very, very interested in your Amazon bills and start asking questions. And what I want to do in this talk today is basically try to make you think about cost for serverless applications from a very early stage. How can we reduce cost and at the same time improve performance, or at least keep the same level of performance, availability, and all the great things that we're getting from serverless architecture? And what are the tools we have and what are the capabilities of the platform to do that? Our talk today is going to focus on two parts. First part, we're going to talk about Lambda functions. How to improve your Lambda functions, how to make them more cost effective. The second part, we'll talk about a much larger serverless architecture. How do you do that? Which components can help you to reduce cost in your modern applications. And we're going to start with talking about optimizing your Lambda functions. So let's talk about Lambda. How can we make Lambda more cost effective? What are the ways we have? So to do that, first of all, you need to really understand what are you paying for. And this is a critical step, and there are a lot of tiny details that you should be aware of. And I want to walk you through the entire process of Lambda billing. How does it work? So how many of you are using Lambda? I'm trying to see, it's really hard. Wow, that's a lot. So I assume you're familiar with the Lambda execution environment and the life cycle of it. For those that are not, and maybe I'll be able to tell some new things to some of you. When you ask us to run your code, basically a trigger, something happens somewhere in the system, a file being uploaded to S3, an API call, or data coming from Firehose or something similar. We will look for an environment to run your code. If there is no such environment, we will start a process that is called init. The init process will take your code, download it, extract it, and that will be the first stage. Then we will create a new environment to run your code and place the code in this environment. And finally, we will execute the init code inside your function. It's really important to understand that everything that is outside your handler, the handler function, will be executed during the init stage. There are some very nice tricks we can do about it. We'll talk about it later. Then we'll go and execute your handler. And this is basically the first time we're doing for you for this specific environment. And if there are additional calls coming in, we will keep executing your handler over and over and over again inside this environment until we run a shutdown. A shutdown can happen in several scenarios. One, it can happen after no traffic for a specific environment for a certain period of time. It's not something we publish. It really depends on the load on the system and some other factors. But you can count on it that if you are calling your Lambda functions over and over again, there is very big chance that you will hit on an existing environment. The other time when we will initiate a shutdown is when you're updating your code. So if you want to force a shutdown on all your active environment, just do a code update. It could be a tiny one, it doesn't really matter. We will shut down all environments related to this specific code. If you've been working with Lambda, you probably know the term of cold start. Cold start is basically this process until your first invocation. When we spinning up a new environment, it can take some time. It can be milliseconds, it can be a few seconds, it really depends on a lot of factors we're going to talk about. And a warm start is when your event is hitting an existing environment. Okay? And there are differences, and it actually can affect your cost. Now, for all this goodness, the only thing I need to do as the maintainer of this system is to define the memory allocation for my function. When defining memory allocation, I'm basically saying how much resources I need to execute my code. And when I define the memory allocation, the system will automatically allocate CPU resources and networking resources based on your memory allocation. This is not something I do myself. This will be done automatically by the system. The more memory you allocate, the more CPU and more network resources you're going to get. This is something very, very critical when talking about cost, because it has a very direct implication, and I'm going to show you. If you need to calculate an estimate of how much CPU resources you are getting, a rough estimation of 1800 megabytes will give you an equivalent for one virtual CPU. Once again, it's not really accurate, but if you need to do this math on your own, you can use this number. I don't recommend that. There are better tools to try and assess how well your function behaves and if it has enough resources. Let's talk about billing now, how the billing works. So I already allocated memory. And based on this allocated memory, it will take some time for my code to run. Okay, we're talking about the execution of the code. And by multiplying those two, I will get a duration, or the cost of the duration. Taking this number, the duration, and multiplying by the number of invocations, the number of events that actually triggered a Lambda, will give you the cost of your Lambda. And this is something that we calculate all the time. Of course, there are some additional charges. There is a charge for 1 million executions, 20 cents for every million executions. There are additional charges for networking, for storage. If you're using it, you should take this into account. But if we're looking only on Lambda cost, direct Lambda cost, it's going to be duration times number of invocation. This will give you the cost. And as you can see, there are 3 parameters that are tied directly into the cost factor of your Lambda function: memory, latency, and throughput. And what we will try to do during this session is basically try to reduce all the above. And if we'll be able to reduce all the above, some of them, one of them, it will have an effect on the cost. This is actually not accurate, because my goal is not to reduce all the above. My goal is to balance all the above to be able to get the best ROI for every function execution. Let me give you a few examples. So let's do a very basic run through. Basic cost calculation. So the cost per gigabyte per second is $0.4016 for every second. If we translate it to the cost for a function with 512 megabytes allocation, it will cost 8 zeros after the dot, 83 for every millisecond. Those are tiny numbers. This is what I said before. This is really cheap and easy to start with. Let's say we have a code that runs for 200 milliseconds. The basic calculation for that, for running 1 million invocation of this code, is $1.66 for your Lambda plus 20 cents for 1 million requests. The total is $1.86 for a million invocation. Now, this is true for x86. Want to save some money? Check if your code can run on ARM. If your code can compile and run on ARM, and today a lot of the code people writing can actually do that, and you switch your environment, your Lambda environment, to use ARM, you're going to save immediately 20% of the cost. Just by doing that. Check if your code is running on ARM, change your Lambda definition to use ARM, save 20%. If this is the only thing you learned from the session, you can leave now. I saved you 20%. And this is really, really basic, and this is something you should look into it. But we will talk how to balance between memory, latency, and throughput, and try to reduce the cost. Let me explain you what balancing means. So I have a very simple task here for my code. I want a code that will compute 1,000 times all prime numbers that are less or equal to 1 million. Okay? Not something very complicated, slightly compute heavy, not something special. So I take this code and I run it with different memory allocations. So you can see that each time I'm adding more memory, the time is being reduced, and what happened to the price? It goes up, right? Somebody wants to guess what happened if I give it 1024 megabytes? Can't really see you. Any guess? Look at that. That's pretty amazing. The execution time will be 8 times faster than the basic option of 128. The cost will be almost identical. This is what I call balance. I increase the amount of memory, but because I'm getting more CPU, in this case, networking is less critical, the execution time, the multiplying each one of the factors, gets me to not exactly, but very similar price. Now, don't get me wrong. If you care only about price and if you have high load on your system, you should go with the first option. This is the cheapest one. And if you don't mind about the fact it takes 8 times more to execute the code. But if you need to balance them, check these numbers and we'll talk later on how to get to this conclusion with some tools. So after finishing with the basics, let's talk about practical things that you can do. The first thing I want to do is to optimize Lambda cold start, and this is on the latency side. Now, it's important to say, if you already forgot, we're talking about the first part, the init and the first invocation. It's really important to say that you usually don't pay for init. Okay, so many things that I'm going to do here will probably improve your code, will probably improve your performance, but has very little implication on the cost, because unless your init time is more than 10 seconds and few other parameters, you're not paying for the init time. But still, there are some very interesting things you can do and save some money. Let's start with something very, very basic. And I think this is not related to Lambda. This is a good software engineering practice. Reduce the size of your packages, okay? First of all, don't build monoliths with Lambda. I don't know if you heard it before, but Lambda is a technology that works great with microservices. Try to break it over and over again. Try to make your code as small as possible. Second, make sure that you reduce dependencies and remove those that are not in use. If you have a library that you're using in one function and it's not necessarily needed in another one, remove it. Don't just copy paste your blueprint from function to function to function, adding more and more dependencies, adding more and more external libraries. This will affect the time of the download and extracting your code. Second, you can use a feature called provision concurrency. Provision concurrency is basically a feature that you're paying for that will tell us to make sure that you have a certain amount of environments that are already warm. We will keep them warm for you. And usually you say this costs us money, and maybe we should not use it because we're talking about cost optimization, not paying more to AWS. But if you look carefully at the numbers, you will find out that when I'm talking about on-demand payment, you know already the numbers. It's the 20 cents per 1 million requests, and this 16666 for every invocation. For provision concurrency, you actually have two numbers you need to take into account. One is the cost of provision concurrency. This is something that you will pay no matter what, use it or not. And then there is the variable cost of invocation duration, which is much lower than on demand. If you sum up both numbers, you will find out that provision concurrency, if utilized correctly, is 60% cheaper than on demand. Now, if you know for sure or very close to that, the amount of invocation that your system needs, like you have a base that you're working with, you can take this base, define it as provision concurrency, and enjoy this 60% save only by doing that. And once again, this requires some work, this requires some analysis to understand what is the needed provision concurrency. Of course, you can use provision concurrency for other use cases, not only cost, if you need to reduce a cold start and many other things, but this is something you can do if you know that you have a certain amount of invocations that are needed to your system. Any Java developers in the room? One. I'll talk to you specifically. So if you're doing Java with Lambda, there is a nice feature called Lambda Snap Start. It has nothing to do with cost. It actually costs you nothing, but it will reduce the time of cold start for Java application. Just enable this and you will get the benefits of Snap Start. Just another way to reduce your cold start. As I said, no extra cost. It won't save you anything, but still worth mentioning. The next one is a very nice trick. So we spoke about the init code, the code that is outside your handler. I'm going to show an example for those of you that are not familiar with that. But the init code is a piece of code that runs only once, only when we build the environment for the first time. Now, to reduce cold start, AWS will allocate a full virtual CPU for your init code, regardless the amount of memory you allocated for a specific function. And this is very interesting because if you put more code that you can move to the init, you will actually reduce your cold start and the price. Take a look at this code example. So this is a very basic code example. Basically, this code, the entire code is running from the handler. So when there is a trigger, the handler function is being called. It's calling another function, basically connecting to an SSM client, getting some data, and responding with this data. Pretty straightforward. Now look at the execution breakdown. Init duration, 657 millisecond. Invoke duration, 888. Total cold invoke time is 1.5 seconds. This is pretty long for very, very basic code. And I'm paying for the build duration of 888. There are parts in this code that I don't need to run over and over again. All the infrastructure, creating the object to connect to SSM client and so on, and get the data, is something I can run only once. And if I change my code and take them out of the handler, so now my handler is only returning the parameter that I got in the init. Take a look at what happened here. So init duration is slightly longer because I'm executing more code. But the invoke duration is only 3 milliseconds. And because I have more resources at this stage, the total cold invoke time drops dramatically. This is half of the time when you have the entire code running in your handler. We're talking about cost. Build duration is 3 milliseconds. Okay, I can't even do the math of how much you saved here. Think about something like that that runs only 1 million times a day. Think about how much you can save with something like that. So think about it. If you don't need it to run in the handler, if you don't need to repeat this call over and over again, you can put it in the init code. Do that. It will save you a lot of the cost. It will make your environment more user-friendly. The call start here is shorter. Moving on to the next thing, and this is actually very interesting. This is talking about latency and memory. How do I know how much memory should I allocate for a specific code? This is a very important question because, as you saw earlier, memory affect latency and both of them affect the cost. So there are several things you should be aware and you should do. So first of all, you need to identify what's the optimal memory for a specific function. There are several things you can do. You can use tools like Lambda Power Tools, I'm going to show it in a second, and the Compute Optimizer. You can use saving plans. If you've been using reserve instances as saving plans on compute, you have the same option with Lambda, so you can basically tell AWS that you're going to use a certain amount of compute for Lambda and pay less for that. And a very important thing is that you need to check this each time you're doing a major change. So in my previous example, when I'm taking a lot of code outside of the handler, I should recheck this again because it might really affect your cost. So let's talk about the tools. So Lambda Power Tuning is an open source tool. You can get it from GitHub. This is a library that's been brought by Alex Casalboni, a good friend of mine and a colleague. And it will take your code and execute it with different memory allocation. And will give you this nice graph telling you what is the optimal setup for your specific code. In this case, you can see that I increased the memory to 1500 and got the best performance. And there is no point to add more because adding more memory will increase the price without any benefit of performance. This is something you can run at any given stage. And you can use another tool from AWS, part of the console, which is Compute Optimize. Compute Optimize, you will tell Compute Optimize to follow a specific function. And after a certain amount of time, it will tell you what is the right setup for this specific function. The main difference between the two is that Compute Optimize needs to run inside your account. So that means you probably want it to run in production. You want real user traffic to this. You want real patterns. With the open source option, you can run it at any stage. You can do it during development. You can do it without sending any traffic. And this is part of what I want you to get out of this talk, of thinking about it in a very early stage. So these were a few ways to tune your Lambda function to make it more cost effective. Now let's talk about optimizing serverless architecture, which today is much more interesting because serverless in 2024 is not only Lambda. There are a lot of tools, there are a lot of options, there are a lot of services today that helps you to build a serverless application. And I want you to be aware of some of them. We won't be able to cover all of them, of course, time limitations and so on, but I'm happy to speak about them after the talk. But I want you to be aware of some of them that will really, really help you to reduce your cost. The first thing you should try to do, and that's true for everything, but for cost consideration, this is really, really critical, is to reduce the idle time of your application. Remember, we are now talking about the entire application, not a specific Lambda function. Let me give you an example about idle time. So this is a very common pattern of using Lambda. There is a function, calling another function, calling another function, calling an external service, and each time one of these functions is being executed, there is wait time. So the first function is waiting a lot for the other two to complete. The second one is waiting once again. The third one is the most efficient, but still very not efficient by calling an external HTTP service, for example, that might take a lot of time. You are paying for this time. It can be milliseconds, it can be seconds, it can be minutes. So you should take this into account and think about it. There's another pattern that I ran into just at the beginning of this week when adding some features to a demo I've been running for a very long time. I have one function calling an AWS service, which is pretty quick. It's DynamoDB, it's super, super quick. Fetch something or write something that takes no time, basically. And then I do another call to Amazon Bedrock. So Amazon Bedrock is a machine learning service that allows me to invoke actions against LLMs. And in this case, I'm taking an image and sending the image as is with a prompt to Bedrock, and I want to get a description of the image and then save it once again to DynamoDB. That's basically the process. What I discovered is that LLM calls, generative AI calls, take some time. And I'm actually paying for this time. And there must be a better way. So we'll have to wait this time because this is how the service is built. This is how it works with the data I provide to it. But maybe there are better ways to do it. And reducing idle time is really, really critical for everything related to cost. So if you take this code, for example, that checks for a status for a job and waits until it replies with complete and waits for a second between every call, that's a waste of money. That's a waste of a lot of money. Think about it running multiple times over and over again. You can take the exact functionality and move it into step functions, which is a service of AWS that allow you to orchestrate your system. And instead of paying for the wait time of the Lambda function, just use a stage that is built into step functions that will do the wait or do the check of the status of this job, and only when it's completed, we'll move forward, maybe execute another Lambda, maybe do something else. Once again, this is not a solution that will work for all. In some cases, this might be more expensive, but you should be aware of that. You should check it at least to see what is more cost effective for you, doing this wait in a Lambda or moving this architecture into step functions and allowing you to use the features of wait and other things. Just think about the cost of this if you're waiting now 60 cycles, 60 seconds for a job to be completed. That is something that will really make the cost of this specific function super expensive. Another thing you can do, you can offload some of your requests. So for example, many Lambdas are dealing with HTTP requests, sending information into an API, a service over HTTP, and just waiting for reply. Sometimes there is a timeout, you need to retry, you need to do a lot of things, and you can offload this request to a service, to Amazon EventBridge with specific EventBridge API destinations. And this is something that will take the API call and do it for you. Now, with all the benefits of saving idle time and so on and so forth, not waiting for the Lambda to complete, there are a lot of other benefits that you usually need to implement inside your code, like authentication support for this API, automatic retries, rate limiting handling, and many other things that you need to do when you're dealing with HTTP requests. And instead of implementing this inside your Lambda code, which you know already has a price, you can offload it into a service like EventBridge API destination. The next thing you can do, and this is pretty straightforward, is to reduce invocations. Okay? This is basically the throughput parameter that we did not discuss yet. And I have a quiz. Actually, it's a pretty stupid quiz, but still a quiz. Which is more expensive? Executing a Lambda with 256 megabyte allocation memory running for 10 seconds or running no functions at all? Anybody thinks the one on the left? No, right? So yeah, that's pretty straightforward. If I'm not running the code, I'm not paying for the code. This is the basic promise of serverless. And the question is, how do I do that? So one thing you can do event filtering. So I'm sure if you're running Lambda, somewhere in your code, there is something similar to what's on the screen right now. I'm getting into my handler, I'm checking a parameter, maybe a parameter I got from the data, maybe a parameter that relates to date or time or anything else. And if it not fits to something I decided earlier, I'm just ignoring and exiting the Lambda without doing nothing. Okay, this is basic filtering of execution. In this case, I'm basically asking the code if a piece of data I get, flea ID, is equal to a certain flea, and the tire pressure is under 32. If it's under 22, I'm doing something. If not, do nothing, exit the code. Why should I get into the code in the first place? Event filtering will allow me to define the event with the right filter. This will basically tell the system, stop processing it. Don't even invoke the Lambda. And instead of running this 6 times, I have the right count. Instead of running it for 6 times, and maybe the 3 that are discarded are super short and very, very small billing, but still I'm paying for them, I will filter them and run my code only for 3 times. And once again, this will reduce your throughput. And another thing you can do event batching. Instead of running a Lambda for every event, take multiple events and run them with a single Lambda. Once again, it's important to say that you need to check this solution and see if it fits for you, because it might work for your use case, it might not. But once again, I'm trying to give you some ideas and some tools to see how can you do something like that. The next one is a relatively new feature, and by talking with many developers, I know that not many are aware of that. Using direct integration, and this is very interesting to try and integrate into your code. So this is a step function system that is heavily relying on Lambda. Still, it's using features of step functions like wait time and many others, but I'm going from one function to the other and executing a lot of Lambdas here. Today with step functions, we have functions SDK integration that allows us to do step functions directly with services. And instead of executing Lambda functions, I can go and talk directly to services. I can go and give a payload to a DynamoDB table. I can take out the response. I can take data from one service to another, and doing exactly the same thing without using Lambda at all. Once again, there is a cost for every step in step function. You need to check if this is the right thing for you. You need to check if you have enough compute power or features inside this integration to do whatever you've been doing with your Lambda code. You might find out that it's not the case, but still, this is a great option. Let me take the example I was talking about earlier, the one with Amazon Bedrock that I used at the beginning of this week. So it's a very basic system. I have an S3 bucket. The bucket is being used to upload images, and what I want to get at the end of the day is a description of every new image inside the bucket stored inside DynamoDB. basic trigger on every new upload to the bucket will trigger a Lambda function. The Lambda function will go initiate Amazon Bedrock invoke, send the image itself encoded in base64 together with the prompt, and at the end of the day, the description will come back to me as a reply, and I'll store it in Amazon DynamoDB. The problem with this architecture is it takes a lot of time. It takes a lot of time to process the request in Bedrock. It's not a lot, it's between 4 to 8 seconds, this is what I saw, but still, this is a lot of idle time. And I can take this code now and basically convert it completely into step functions. I do have one Lambda, and this Lambda will get the information from the file, will process the file, but then it will hand off to Bedrock. Bedrock will do its work, finish, and hand off directly to DynamoDB. And actually, this is something that will reduce the execution time of my Lambda. Once again, I need to check if this is cost effective. My guess in this case, because it takes a few seconds to Bedrock to finish that, it's probably going to be very, very cost effective. Another thing with direct integration is something that a lot of us are doing is working with APIs. And usually the mapping is one-to-one. So we have an API call to a Lambda, and Lambda then doing other things. You can do direct integration with APIs today. So instead of calling the API, then going to a Lambda function, you can go directly to the service. Once again, it's possible that you won't be able to do that with your application and with your code, because you're doing things inside the Lambda that direct integration won't let you do, maybe things related to security, authentication, other things, but you should know that this is possible. You should test and see if this is something that you would like to integrate inside your code. And as I said, there are a lot of options. I just showing 3, but take into account that both with step functions direct integration and with API gateway direct integration, there are a lot of things you can do to make your application more efficient. So I really try to give you a few examples, really try to bring those ideas that will make your application more cost effective, that will allow you to actually reduce cost and use all options, all the things that we provide you with AWS serverless architecture. Few things to sum up. So first of all, I think understanding the payment process is critical. You as a developer need to know how cost is working with Lambda. You need to understand the serverless lifecycle, you need to understand the factors that affect performance, and you need to understand the different pricing models. So provision concurrency and saving plans and other things are very, very important. The other thing is that you should try to simplify your architecture. You should try to think about those things that will make your application simpler, less idle time, and of course, less moving components, and re-evaluate for every major change. This is really critical because it has a direct effect on cost. And I think one of the most important things is choose your battles. I think this is something I've been using a lot in different scenarios, especially with kids. But choose your battles when you're doing cost optimization. If you have a function that runs once a day, don't spend your time on trying to optimize that. Look for those that either process a lot of data or are user-facing and being invoked many, many times. Those are the ones that will actually move the needle for your bills. So choose your battles wisely. Werner Vogels usually at the end of his talk is saying go build. I'm going to say go save. So this is my ask from you. And if you want to get the slides of this talk, they are available in this QR code, or go to slides.boaz.cloud. This is yet another serverless website I'm running that processes new slide decks for me. And thank you very much for listening. I'll be around. I think we have some time for questions if there are any. Thank you very much, and I'll be in the Ask Me Anything corner after the talk. Thank you.
Boaz, thank you so much.
Thank you.
Guess, is there any questions at the Slido platform? Just guess. Tell me.
No. Yes.
There are no questions. Is there any questions in the audience? Raise your hands. Maybe. Maybe yes. Maybe no. Maybe yes. Maybe no. Guess why there are no questions?
I have no idea.
You have no idea.
They want to go to lunch. That's
Definitely,
my first guess.
definitely. That's a correct answer. That's a gift for
thank you
you.
very
And
much.
I think questions are, yeah, they start coming actually. I run a container in Lambda. Do you have cost and performance suggestions for this?
Yeah, so containers in Lambda is an interesting concept. For those that are not aware, you can actually take a container and spin it as a Lambda function or as a runtime environment. I think many of the things we've been talking here are relevant to containers as well. So memory allocation, other things. I would always suggest for those running containers in Lambda to check other options as well. Check the other runtimes, EKS, ECS, check Fargate. You might be surprised by that. If you're running containers for the runtime, probably this is something that you can get only from this, but check other options. This is something I always recommend. If you have a technology that can run on multiple platforms on AWS, check all of them before making a decision which one to do.
All right, thank you. So last time, do we have any questions from audience? I see no questions. Okay, do we have? No. You see. What could you recommend to save costs?
On RDS service. Ooh, nice. So not 100% related to serverless, but I do have a talk talking about improving performance of non-serverless components working with serverless applications. And one of my recommendations is use RDS proxy. I don't know how many of you are familiar with RDS proxy. RDS proxy is basically sitting between your code, in this case might be Lambda or something else, and your RDS server, and basically being a proxy. I know few customers that saved them like the cost after implementing RDS proxy was 1/4 of the original cost of RDS before doing that, mainly because it handles connections much better, it responds much better. So if you're using RDS with Lambda, consider that.